Hi ladies, this is lesson 5.3. It's about kites and trapezoids and some of the properties and characteristics that they have. So we've already in chapter 1 defined kites and trapezoids, so we know they're both quadrilaterals and we know some of the special features that they hold, which makes them a kite or a trapezoid. But today we're going to get a little more into their properties and why they hold true. So on your note sheet, you have several vocab terms: kite, vertex angles, non-vertex angles. Those are all definitions for kite. And then trapezoid, isosceles trapezoid, base, and base angles. Those are all vocabulary terms that deal with trapezoids. So to start, you have this chart on your note sheets. It's got all of those vocab terms. There's a spot for a definition and then a spot for a picture. So please pause the video as you write these down if you don't get the whole definition, because I just have them up here and I'll just remove the boxes. But our first term is a kite. So you already know the kite is a quadrilateral, and it has exactly two distinct pairs of congruent consecutive sides. That means two of the congruent sides, a pair of them is next to each other, and the other pair is also next to each other. So if you were to draw a picture, here's what your picture would look like. So if you think about this, this looks like two isosceles triangles. And if you were to just kind of split this up and visualize it, there would be your two isosceles triangles. You have one on the top and one on the bottom. I'm going to remove that line just so you shouldn't draw that in your picture because that's not part of a kite. But just so you can kind of see, there we go. So you can see how a kite is made up. Now if you think of an isosceles triangle, the vertex angles, this would be a vertex angle of an isosceles triangle. And the vertex angles for a kite are the same. They would be the two vertex angles of the two isosceles triangles. So the two angles between each pair of congruent sides are your vertex angles. So in the purple, those are your vertex angles. And they're the same as the vertex angles of the isosceles triangles that make up that kite. The non-vertex angles, those are just the other angles, the other set of angles in a kite. So if these are the vertex angles, then the other two are the non-vertex angles. Then if we move on to trapezoid, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So if you were to draw your picture of a trapezoid, you would point out that one set of sides is parallel, but the other one is not. So the top and the bottom side are parallel, but the the left and right side are not parallel. With an isosceles trapezoid, you have the characteristics of a trapezoid where you have one set of parallel sides, but the other two sides are the same length. So those two are congruent sides. And then the bases and base angles also deal with trapezoids. So the bases are the parallel sides of a trapezoid. So these two sides are the bases. And then the base angles is a pair of angles that share a base as a common side in a trapezoid. So here you can see your picture. So the green angles, those two angles share that side. The top base is their shared side. And then the purple angles, the shared side, so those two angles share that base as a side. The bottom base is the side they share. Alright, so now if you look in your note sheet, it asks you to use patty paper. Now you could use a marker and regular paper if you wanted, but you just need to be able to see through the paper. That's why patty paper is helpful. But you could use wax paper if you have that at home, or any kind of white or thinner paper would work for this. But we'll kind of walk through some of the properties of kites and how and why those are true. So first, you want to draw two connected segments of different lengths. So you're going to fold your paper in half through those vertices, or through those endpoints. So you would fold the paper right here. This would be your fold line. And then you would trace on the other side. And then when you unfold, you're going to get a kite. Okay, so again, a kite is made up of two isosceles triangles. So these are our two isosceles triangles, and I'll just kind of resize it here so it fits together. So these two are congruent, and those two sides are congruent. So we'll kind of just refer back to this diagram that I just drew for those of you that are at home not doing this activity along with us. So we're going to look at the vertex angles. We're going to look at the non-vertex angles. So you could start with a, just either by looking at this diagram or use a protractor. And the first thing that you should see is looking at those two vertex angles and the two non-vertex angles. Again, these are your vertex angles, and these are your non-vertex angles. So just looking at those two sets of angles, you should notice that the non-vertex angles are congruent. Alright, so just the reason behind that is these angles, the vertex angles, these are not necessarily going to be congruent because the triangles are not necessarily congruent. Okay, so yes, they're both isosceles triangles, but it's not always going to be true that the vertex angles are congruent. So then let's look at the non-vertex angles. In an isosceles triangle, we have the base angles congruent. So the red angles, so the base angles of the top isosceles triangle, those are both going to be A, because they're the same. And the base angles of the bottom isosceles triangle to form the kite, those are both going to be B. So these two non-vertex angles are both going to be A plus B. Whatever A is and whatever B is, the two non-vertex angles are going to be congruent. So then let's draw the diagonals of our kite. And again, I'm just going to refer to this diagram here that has the two isosceles triangles. So draw the diagonals. So I'm going to erase all these congruent markings. And one of those diagonals is already there because it's part of the triangle. But if we were going to draw the diagonals, we would draw the diagonal connecting the non-vertex angles, and we would draw a diagonal connecting the vertex angles. I'll use the dot line. And this is a little off, but I can kind of rearrange it here so it fits. There we go. All right, so those are our two diagonals. How are these diagonals related? So take a look at your diagonal that goes from your vertex angles. So that's the one that I have in dotted line. And if you can remember the properties of an isosceles triangle, So here's our isosceles triangle. That's what we know about an isosceles triangle. Well, in chapter 4, we discovered that the altitude of an isosceles triangle was also the angle bisector of the vertex angle, and was also the perpendicular bisector of the base. So if you look at that dotted, that purple, this right here, the diagonal connecting the vertex angles, what's going to be true about it? And this gives you the kite diagonals conjecture. Well, if this is a diagonal connecting the two vertex angles, it's going to be the angle bisector of both vertex angles, and it's going to be the perpendicular bisector of the base, which in a kite, the isosceles triangles share a base. So that means that this is going to be 90 degrees, and then it's going to make these two pieces congruent. So that the diagonal of the vertex angles is going to be the perpendicular bisector of the other diagonal. So first we know that the diagonals of a kite are perpendicular. And then second, we know that this diagonal, this purple dashed diagonal that I have in my kite, bisects the other diagonal. So the diagonal connecting the vertex angles of a kite is the perpendicular bisector. Of the other diagonal, which is the diagonal connecting the non-vertex angles. So next you should fold along both diagonals to either, well actually we already identified this. So yes, the kite angle bisector conjecture, if we look back at our properties of isosceles triangles, we know that this bisector also bisects the vertex angles because of the properties of isosceles triangles that we identified in chapter 4. So the kite angle bisector conjecture says that the vertex angles of a kite are bisected by the diagonal. So all these properties that we're discovering about kites, we have already discovered them, but we discovered them using isosceles triangles. But now with a kite, we're just putting those two isosceles triangles together. So the next step, the next polygon we're looking at is a trapezoid. So a trapezoid is quadrilateral, and we know that it has one set of parallel sides. So the first step is I've asked you to draw a trapezoid. And then you should use your protractor to measure each angle and then the sum of each pair of consecutive angles. So I'm going to use my protractor here. All right, and here my first angle is about 65 degrees. And then my top angle is about 115 degrees. And then over here, it's like about 85 degrees. And then if I come back to this last one, it's about 95 degrees. All right, now it says, find the sum of the measures of each pair of consecutive angles between the parallel bases. So I'm looking for the angles between parallel bases. So here's one set between the parallel bases. And then here's my other set. All right, so if I add up 115 and 165, I get 180 degrees. If I measure up 85 and 95, I get 180 degrees. So what do I know about these? If I were to draw a conclusion and they were both equal to 180 degrees, what do we call that? The consecutive angles between the bases of a trapezoid add up to 180 degrees, or in other words, are supplementary. And you should find that true about your trapezoid too that you drew. If you measured the angles, they should be supplementary. So now we're going to measure each pair of base angles. What do you notice? This is with the isosceles triangle, and so you can use this isosceles triangle that I put up on your note sheet. So measure each pair of base angles. And what do you notice about the base angles of each trapezoid? So take out your protractor, and our base angles, we're going to measure all of those. So here's one base, here's another base. So this is one base angle, one pair of base angles, and this is another pair of base angles. So you should take out your protractor and measure those base angles, and then make an observation. So if I'm looking at this isosceles trapezoid, and I measure the two base angles that are in red, I get 100 degrees for both of those. And if I measure the two base angles that are in green, that pair is both 80 degrees. Now, if you think about this isosceles trapezoid for a second, and you were to extend both of these sides, you would have to extend it the same distance, and you would end up with an isosceles triangle. And in an isosceles triangle, base angles are congruent. So just a connection to chapter 4, triangles again, but the base angles in an isosceles triangle, the base angles in an isosceles trapezoid are congruent. So in an isosceles trapezoid, there's a single line of symmetry, and it passes through the intersection of the diagonals. So if I were to draw these diagonals, my line of symmetry would go through this point. And if you're going to compare their lengths with a ruler, you're going to find that those two sides are congruent. And you're going to find that those two sides are congruent. So now if you look at this trapezoid, you see 4 triangles inside of it. You see 2 isosceles triangles, and then you see 2 other triangles. And those 2 other triangles, you have a side congruent to this side, the triangle, another side congruent to another side, and the third side congruent to the third side. So you have 2 isosceles triangles, and then the other 2 triangles are congruent. So that should tell you that the diagonals of a trapezoid, of the diagonals of an isosceles trapezoid are congruent. All right, and then the last problem that you have on here is this extra example where you're finding the measures of the lettered angles. So you want to think through the properties you know about an isosceles triangle, or now that the properties we've discovered about a kite, and draw some conclusions. So the first thing you know is these 2 are the vertex angles, and vertex angle, that this diagonal, not only does it bisect the vertex angle, making this angle congruent to this angle, and this angle congruent to this angle, but it's also perpendicular. So as a starting point, you know that B is 90 degrees. All right, now your next step, you look at this triangle that includes D. Notice that it's an isosceles triangle. Okay, that means that these base angles are congruent. So this one that we already have, and angle D, are congruent. So angle A and angle D ultimately are congruent. And I already had my vertex angle, which is 90 degrees. So angle D, 180 degrees in a triangle, minus the 90 degree angle that I already have, divided by 2 because it's an isosceles triangle. That gives me 45 degrees. Since I know that angle A is congruent to angle D, I know that A is also 45 degrees. Which also it would be congruent to this, because here's another isosceles triangle that is congruent to the isosceles triangle that contains angle D. Alright, so we've got B, we've got D, we've got A. Now to find C. Well, if you look at C, you also can see that it's an isosceles triangle. And in this isosceles triangle, we know the base angles are both going to be 60 degrees. So if both angles are 60 degrees, then this whole big angle here, which is twice as big as C, we know that 2C equals 180 minus 60 times 2. So 2C is equal to 60. Therefore, C is equal to 30 degrees. So please jot down any questions that you have, and I'd be happy to go over on one-on-one or next time I see you in class. Thanks, girls.